All right, folks. This video is what I'm going to call a pre-calc or pre-calculus review. All right. Although there is a question in the one of the pre-lectures about this very topic. Okay. I'll title this thing "Domains of Compositions." I'll put it in a folder on YouTube though about the pre-calc review. Okay. Um, so essentially, what we're doing here is we need to compose functions, which use that little circle as the symbol for that. And so most folks that are tackling these homeworks did the compositions fine. The issue becomes what is the domain of a composition, and so that is something that's covered in pre-calculus when you study. First, you study domains of functions, then you study composition of functions. And when I teach the course, I always ask a lot of questions like this because they're kind of tricky. There's sort of two things that we need to consider. All right, once we get our composition set, once we have the composed function, we have to look at it and see if there's any x values that cause us problems, and if there are, we have to eliminate them. The other thing that we have to do is look back to what I like to call the inside function of the composition and consider its domain. Consider if it had any problematic values. And we're going to see that we have to eliminate those as well. All right. So, for instance, this is actually, I believe, pre-lecture 2.5, I think it's question 1, is this topic, okay? So by the time this gets posted, you might have already tackled it. I emailed quite a few people back this explanation, so I figured it warranted a nice video. Some of you folks, some of the people who emailed me had 8s as these constants. If you did, your 8 is printed in red. If you have another number, in general, WebAssign sometimes randomizes different digits from one student to another. Those are always indicated by the red digits in case you're curious. So some of you may have a different constant right there instead of an 8, but the process is going to be exactly the same. Okay, so let's step through a few of these. So first of all, let me consider, before I even get started actually composing, let me just express the domain of each of these functions using interval notation, because we're going to want to reference that information later, so we might as well just have it written down. So I like to write my domain notation is DOM of f. The domain of my function f is all real numbers except 0, right? We know we're not allowed to divide by 0. The only value that makes this bottom 0 is letting x itself be 0. So the domain would be negative infinity, comma 0, union 0 out to infinity. And just a note or a review on interval notation. Remember, infinities always get round brackets. Because we can't actually plug in the value infinity. It's not really a value, more of a concept. So infinities always get round brackets. And then here we can't actually plug in 0, so each 0 here gets a round bracket, right? If we put a square bracket on one of these or on both of these, that's telling the reader that 0 is included, but that's a problem because we can't divide by 0. Okay, so we've got domain of f, and domain of g is similar in the sense that we still can't divide by 0. And now there's only one x value that makes this bottom 0, and that would be if x is negative 8, right? Negative 8 plus positive 8 equals 0. So x cannot be negative 8, so we're going to have the domain will be negative infinity up to, but not including negative 8. Right, so round bracket on that negative 8. So this is all the numbers to the left of negative 8, and then union, another round bracket, negative 8, out to infinity. That's all the numbers to the right of negative 8. Again, round brackets excluding that value, and then at the end, put our round brackets on our infinities. Okay, so that's kind of, that will be relevant for different compositions at different times. So let's do this one first. Let's say, I'll probably do all of them. Let's do f composed with g of x, okay? The key of why this domain stuff happens is we read this, it looks like a little circle. When I type it back to people's emails, I use a lowercase o, but in WebAssign, there's actually a specific symbol for that, a composition. But I read this as f composed with g of x, okay? So we have a function f of x, g of x, and we're forming a new function, f composed with g of x. But the way that we compose that is by doing this. It's f of, so I kind of pronounce the parentheses sort of as the word of, right? Just like we say f of x. So here f of the inside function, g of x. So we're doing f of g of x. And this representation right here shows us why the inside domain is crucial. In other words, g of a particular x value has to exist. Otherwise, we can't calculate the composed function value. So, okay, so let's finish this process. F of g of x really means f of, well, what's g of x? So I'm kind of working from the inside out. G of x is this, x over x plus 8. X over x plus 8. Okay, cool. And now f tells me to take my input, right? F is equal to 8 over the input, or 8 divided by the input. So f of this expression means 8 over the input of x over x plus 8. All right, that's how I would work that out. What is this? Why did I put the 8 like up there, and why did I leave that blank space? Well, the way I like to do this is what's happening here is 8 itself is a ratio, right? It's a rational function. It's got a numerator and a denominator, right? So down here, this denominator, whatever the input of that function is getting to be this denominator, is going over there. But in that case, this denominator itself is a fraction. And so the way I like to do that is if I have something, a big fraction, indicated by this fraction bar, but one of the pieces of it is itself a fraction, then I like to represent the other piece as a fraction as well. So I left a little space so I can just call 8 over 1, right? That means the same thing. And the reason I like to do that is because now I want to do the old technique. Essentially what I'm doing is I have a fraction divided by a second fraction. So we want to sort of flip that bottom fraction and multiply, right? That's our technique. So I'm going to have 8 over 1 times the reciprocal of this thing, which is x plus 8 over this x, appears in the bottom right there, and that's what I've got, right? So now I can clean up this this composition right here. So multiplication like this, I'm just going to do top by top, bottom by bottom, right? Multiplying fractions, we don't need any kind of common denominator. We just go across the top, go across the bottom. Essentially, since this top has a plus sign, it might be helpful to wrap the parentheses right there. I need to distribute this 8 to both of those pieces right there, and then the bottom is just going to be 1 times x, which is just going to give me x. Okay, so I'm going to get 8x plus 64. I'm sorry, 8x plus 64 over just a single x. Alrighty. So that's my composition. That's my final answer, and in some emails, I refer to that as the final rule, right? What do I mean rule? Well, the rule is what tells you what to do for a function. So if I look to my function g, the rule is saying take the input and then divide it by the input plus 8, right? And this rule over here is just saying take 8 and divide it by your input. So the rule is just the formula. I just like to use that phrase rule. So we have the final rule here is 8x plus 64 over x, okay? It's good to show all that work. If you're showing this on paper, you want to show all that work. At this point, though, since now I want to discuss the domain, to clean up the board and get some more space, let me erase that work. But I want to keep the final answer here. So just to tell myself that this was f composed with g of x, right? So I want to leave that there. And I actually want to leave this piece here, too, because that notation is actually helpful here. So just to buy some space, let me just write my final answer up here. Final rule, 8x plus 64 over x. Okay. So, no big deal. So that's like the first answer or first thing that you have to do for this homework. The next thing, though, now says, what's the domain of this composition? F composed with G. Okay? I didn't really put the of x here. So in the same sense, I didn't put the of x there, right? Because the name of the function is f. And so the name of this function is f composed with G. So the domain of this new composed function, those of you who emailed me regarding the same problem, the issue here you had is you see the x in the bottom, and you say, well, x can't be 0, right? I can't divide by 0, so x can't be 0. And that seems, when you look at this final rule, that seems like the only problem, right? That really seems like the only problem. And so what a lot of folks said is they essentially told me that domain, but they said it as this, negative infinity to 0, union 0 to infinity, all right? Meaning that the 0 is a problem. So sometimes I like to do domains on number lines as well, right? So at 0, let me put 0 here. 0 is a problem, right? 0 doesn't work. So it's not part of the domain. So I'm going to use red and kind of use an open dot to indicate that that's not going to be part of our domain. What's going on now is essentially if that's not part of our domain, then you're claiming that this portion of the line is, right, which is from 0 to infinity, this interval, and this portion of the line is, right, which is negative infinity to 0 or coming backwards. The problem is, let me get rid of the domain notation. If this includes all numbers to the left of 0, then negative 8 lives in there, right? Negative 8 lives in there. So what folks are tempted to do is say, can I do f composed with g of negative 8, right? And over here, if you just use the final rule, this final rule is handy because it's like a shortcut towards a calculation, right? So that's a shortcut, but we have to worry about the domain here, so of the inside function. The final rule seems like the only problem is the x being 0. And if I let x be negative 8, then the bottom is negative 8, right? And then regardless what happens to the top, the bottom is negative 8. That seems like it should be okay. However, f composed with g of negative 8 is really this. It's really a two-step process. And again, this is a shortcut. The final rule is a shortcut so long as we're allowed to plug in the values. But really, there's a two-step process. What happens is if you have an input, you have to plug the input into the g function first, right? So you plug an input into g. G does something with that input and spits out the output, which we call g of x, right? It spits out some kind of y coordinate, some kind of function value of g. And then we take that number and plug that number into f. Okay, that's how the two-step process actually works. And so what you might see is f composed with g of negative 8, it's really f of g of negative 8, right? And that's a problem, right? Because negative 8, g of negative 8 doesn't exist, right? We argued what the domain was earlier, that it did not include negative 8. And if you try to do g of negative 8, what you're trying to do now is f of, right? So again, this is the two-step process. The first step is evaluating this. Well, what's that going to give me? That's going to give me negative 8 over 0, right? And that doesn't exist. This expression inside these parentheses does not exist. It's like a figment of your imagination. And so if you just take this figment of an imagination, you can't plug that figment into f, right? It doesn't exist. So since this piece doesn't exist, negative 8 can't make it through the two-step process, can't make it through the composition, and so we have to reject it, right? So we reject negative 8. That's the mechanics of why that happens. In other words, that's sort of the motion that you would go through, and you'd run into a problem. So it's not possible to send negative 8 through the composition. Sort of the easier way of, or in other words, once you establish that, once you believe that, once you kind of internalize that that concept, then the way I think about it is, again, I like to use a number line often for domains. So the way I say is do your composition and then look at the final rule. And anything that's problematic in the final rule is problematic, right? So x can't be 0. So I said that earlier. So at 0, I think I wanted to use a red pen. And we'll put an open dot on that line right there to indicate that 0 is no good, right? 0 is problematic because in the final rule, it's no good. The other thing to look at is the domain of the inside function. And the inside function is going to be this. So if you write it like this, it's the one that lives inside those parentheses. Otherwise, if you're just looking at the composition, it's the one closer to the x, right? Because we work this way, so it's the one closer to the x. The domain of that does not like negative 8, right? Negative 8 is problematic in there. And so let's put negative 8 right there. Indicate that that point's no good. And so therefore, how many intervals do I have? Well, I've got this interval. I've got this interval right here in between those values, and then I've got all these numbers larger than 0 are still okay. So I've got 1, 2, 3 intervals for this domain. So now we will have negative infinity to negative 8 union negative 8 to 0 union 0 to infinity. Alrighty. And there we go. Okay. One thing, so sometimes students say, well, what about the outside function? Do we have to look at the domain of the outside function? Well, let's notice something, and sometimes this changes up. Sometimes problems might fix themselves. But if we look at, in this case, the outside function, as I would call it, is f. And 0 is problematic in the outside function, right? We ended up rejecting 0, but we didn't really reject it because we looked at the outside function. And in fact, throughout that whole discussion, I never went back and actually looked at f. Right? All I looked at is the final rule, and then I looked at the inside rule. So again, the inside rule is important because of the two-step process. If there's a problem with the outside function, and it's going to cause an issue, it will sort of still rear its head right here, right? It'll still be present. In other words, here was divided by x, that's still going on there. So really what I'm looking towards is the final rule and the inside rule. All right. To show that 0 doesn't work, let's actually see through the process where we run into trouble is if I try to do f composed with g of 0. Again, we'll do the two-step process. So that means f of g of 0. Now 0, he was fine in the inside function. Right? Negative 8 was the only problem for that function. 0 is okay. So in other words, let me work within these outer parentheses right there. What I'm going to do is f of, and then g of 0 is going to give me 0 over 8, right? 0 over 8. And anything 0 over non-zero is equal to 0. So this is really f of 0, right? So that was step 1 of the two-step process, and that was okay. But now what's f of 0 doesn't exist, right? We already said that was no good. So in other words, this outside rule is kind of happening right when this happens. That's where the problem is going to occur. So the two things you want to look at for a composed function is final rule once you're done, and then also the original inside function. Those are the only two things you got to look at, okay? And then if it's bad, you kick it out. Any other points that survived, both of those eliminations are good to go, okay? I won't do all the compositions. In the homework, I think you're composing this in the opposite direction, G composed with F. If you do that, if you were to do G composed with F of X, you got to do the composition. So I'll let you do that on your own. See what the final rule of the composition looks like. If there's anything in the bottom that's bad, take those numbers out. But who's my inside function here? F, right? What number is no good for F? 0. And so before you even start this process, we should, at this point in this discussion, realize that 0 is out of this domain, right? The domain of this composition can't contain 0 because it's problematic for our inside function. Then you still need to look at the final rule, okay? The one that's kind of interesting to me, another one that I'll do quickly, is F composed with itself. Fof, right? F composed with itself. Calling it Fof. Again, that's not really a letter O, it means composed with. What is this? Well, that's f of x, plugging a function into itself. So that's f of, again, I always work from the inside out, f of 8 over x. Well, now f says take my input, do 8 divided by the input. So it's 8 over x, all right? And just as I did earlier, this, convert that to a fraction just so I could flip and multiply and have everything line up nice. So now I've got 8 over 1 times the reciprocal, the flip of this, x over 8. Those 8s are going to cancel out. And so I've got x over 1, which is just x. Cool. So f composed with itself of this x is just itself x. In pre-calc, we call that the identity function because you plug in an input and what's the output? It's exactly the same thing. Now, if you just look at this function, you'd say, well, that's just the line y equals x, right? That's just a straight line, exists everywhere, no problems. Domain should be all real numbers. So here, the outside the domain, scratch that. The final rule domain, in other words, I look at my final rule, this domain is all real numbers. So it hasn't kicked anybody out, right? No numbers have broken a rule so far. But then we look back to the inside function, is f. F cannot take 0 as an input, and so therefore the overall domain here can't take 0 as an input. Okay, so in this case, domain of f composed with itself is all numbers except for 0. The only problem comes from the inside function. 0 can't be plugged into there. So negative infinity to 0, union 0 to infinity. Okay, just one more time to reiterate. This is the shortcut. So what you want to do, it's useful. It's useful because if you want to plug in any other number other than 0, it's just, that's it. That's what you're going to get, right? So the shortcut is useful, but sort of in conjunction with the domain, right? In other words, knowing what's not allowed to be plugged in is important, and then the rest of the numbers, then you can use this, okay? If you try to do f composed with f of 0, so again, I like to do the two-step process just to watch this issue up here. It's going to be that. F composed with f is f of 0. F of 0 is 8 over 0. So this is telling you 8 over 0, right? But this doesn't exist. And if you get a piece of this calculation, a piece of this expression that doesn't exist, then you can't go any further. Then the whole thing doesn't exist, right? So there we go. Okay, so hopefully that sounds familiar. Maybe now that you see this, you'll say, oh yeah, I remember somebody talking about that in pre-calculus. But if you've never seen it before, you've seen it now. So there we go. All right, guys.